In this video we're going to look at systems lifecycle, and it's called the hard approach. The reason why it's called a hard approach is because it deals with the development of projects, and it takes a very rigorous and programmed approach to the development of the projects. So it sets out various steps, and each step is completed, and then the project moves to the next step. So there is a flow of activities, one following the next, and because each one must be completed before the next one is started, it's called a hard approach. It's a programmed approach to the development of projects, or to the development of systems. So we're going to look at the Systems Development Lifecycle, SDLC. The Systems Development Lifecycle, and that's the core of what we're going to deal with in this session. Now, the Systems Development Lifecycle is referred to as the hard systems approach, as I said earlier. This is what we mean by the hard systems approach, the Systems Development Lifecycle. The model is designed to resolve structured problems. So when problems arise, they're dealt with in a very methodical manner, one process following the next. Everything is set out almost in a linear fashion, one task following the next, so that it's structured, and the model is set out in this structured form. Organizations are complex systems that require information systems to support daily tasks to long-term projects. Organizations are complex. They deal with people, they deal with different departments, and the flows of information within even medium-sized companies can be very complex, flowing in all sorts of directions, flowing from the top to the bottom, from senior management down to the shop floor, and from the shop floor back to senior management. But it can flow diagonally as well, from one department to a different department. So information is complex within organizations, and the organizations themselves are complex. So developing a system to incorporate the complexity is a difficult task. The SDLC is used to manage information systems and project management. Progressively, this is done through computerization and through the use of specialist software. But it may also use off-the-shelf software. For example, Microsoft Project may be used to help facilitate decisions in complex organizations. It helps build information systems that improve efficiency and effectiveness within the organization. That's the whole purpose of this exercise. It's to develop systems that will improve the efficiency and the effectiveness within organizations. The efficiency, the cost basis upon which projects are worked out. Looking at costs, controlling costs, and looking for alternative ways of processing resources to be more efficient. So there's a constant quest within organizations to look for cost-saving measures. Clearly, the more that's saved on cost, the greater the profitability of the project. It's essential that the information collected is accurate and it's fed into appropriate software or into appropriate systems to enable accurate outcomes at the end, to enable the management to work on these outcomes. So we're here developing or looking at the development of systems which will improve the efficiency of organizations. Now, the model is in stages, which involves careful planning, executing, and management of information systems. So we must see the systems development life cycle model. We see it in stages. It has a beginning and it has an end. Well, perhaps the end is a bit too dramatic. Perhaps instead of saying end, we have review and analysis, and it may start off again another cycle of reviewing. It's the constant process of constantly looking for efficiencies, constantly looking for better ways of working and better ways of doing things. But the process itself is in stages, and that's what we're going to look at. It's costly, it's time consuming, and requires specialist and knowledge workers. It requires specialist workers and also knowledge workers to assist in the development of information systems. Specialist workers, specialist engineers, specialist accountants, specialist marketing personnel, specialist HR personnel. It depends on the nature of the business and what's been produced. But generally speaking, there will be specialists, highly focused individuals who have got specialist knowledge and background in that particular field. But also there will be knowledge workers. Knowledge workers are workers who have expert knowledge of computer systems, let's say, and who can acquire the information, can gather the information that's within the organization. They'll probably gather data and process it into information. It may already be processed, so they may be able to gather the information. But one way or the other, the knowledge workers will acquire the data or the information and add it into the system and organize it and structure it so that management can see exactly what the system is and where efficiencies can be brought about. There are various models here that are used and are put forward. And each of them have their merits, and each of them, I suppose, have their drawbacks. However, one sort of stands out as particularly useful, and this is known as the Waterfall model. It's the oldest and indeed it's the most commonly used model. The Waterfall model follows a structure. It can be easily applied to all industries and fields. It's a waterfall, and like waterfalls, the water falls from one level to the next. So if we look at this in terms of an organization, we could see the waterfall model as a sequential design process. It flows steadily downwards like a waterfall. So we start with conception. Someone gets an idea within the organization. It's just an idea. It's just something in somebody's head. Then it's initiated. It's started. The idea seems good, so they want to try and develop it and try it out. So they explain it, they work it out perhaps on paper, they make presentations, they talk to colleagues, and through this we get analysis. We get feedback and criticisms and objections, and it needs rethinking perhaps. The idea is good, but it's not going to work as presented. So through conversations and presentations and talks with other members of staff and so on, there's some sort of analysis. Then there is a design. From the analysis there is an outcome, a design. A design is put forward for a particular project. And having got the design, it's constructed. Then it's tested. And if the testing is good and the construction is efficient and perhaps not that costly, it could go into production. And once it's in production, the production system is maintained. So we have a waterfall. It starts with an idea in someone's head, just a conception, so some sort of vague idea. and it ends up with a production system making something, doing something, processing something. It could be processing information, or it could be the way information is processed, or whatever. And it's maintained. The system is maintained, so it becomes an integral part of the organization. So it's the waterfall system. It's what we use without calling it the waterfall system on many occasions. If we just take this concept and just rewrite it, just change it around slightly, we could get something like that. We say, again, it's the waterfall system. We start with a feasibility study, we go to systems investigation, systems analysis, systems design, execution, making the thing, and then review and maintenance. So we start with a feasibility study. We start here, in this case, further along the line. We don't start with the idea. We could factor in the idea into the feasibility study. Somebody has an idea, then we talk to others about the idea, we share the idea, we look for criticisms. Perhaps the person who came up with the idea becomes the champion for the idea. And through all of this, it's like a feasibility study. They're checking for the criticisms, for the downsides. And if it passes through that feasibility, it could go into an investigation, looking at the system to investigate whether the system can be developed and whether it will integrate with what's already in place. And so on through the waterfall. So we're moving here from left to right. Now let's start and look at each of these in turn. And we'll start with the feasibility study, and we'll just work our way across these various steps right down to the end. So we'll start with the feasibility study. Organizations are constantly evolving and re-engineering in order to compete within the market. So organizations are not static institutions. Organizations, companies, broader organizations are constantly evolving. They're constantly changing. They're taking in new information from the marketplace, from technology, new ideas from workers coming in, from graduates and people with diplomas, and people on the shop floor who have got good ideas may come up with ideas as well. So organizations are constantly changing, constantly evolving. As technology evolves, organizations need to replace old information systems as new systems introduced opportunities for organizations. So technology is constantly knocking on the door. Technology is constantly evolving. There are new ways of processing information, new ways of looking at the organization, and providing these are cost saving and providing they are feasible, they can be introduced, then they will make large or significant changes to organizations. The feasibility stage reviews present systems and detects any shortfalls, any errors in speed or accuracy or efficiency of the present system. So the feasibility study is constantly monitoring what's happening right now. If the company is making something, the feasibility is constantly looking at what's going on right now. Can it be improved? What are the measurements? It's trying to get metrics about costs, about the numbers produced, about the design, the layout, and constantly looking at improvements that could be made to this, which would improve the efficiency and the costs of production. The feasibility stage produces documents on the effectiveness of the present system and also offers best possible solutions. So in looking at the existing system, looking at it critically, looking at how it could be improved, then new systems can be imagined and brought into play. In other words, varying the old system, cutting out parts of it or adding new parts. But the idea is to lead to better efficiency. So it's through radical and critical analysis of the existing system that a new system may emerge. During the feasibility stage, the following needs to be considered. Legal issues. The new system does not breach any laws, international, European, corporate laws. So it's important that when looking at the existing system and devising a new system, that the new system is legal. It can't be dangerous for workers. It can't violate the workers' rights. So there is a legal dimension in the development of a new system. That's important to note. Next, it's the acceptability of the system. Will the system be socially accepted by staff? Will the new system require a complete shift from normal working activities? So looking at a new system, the feelings and the attitudes of the workers, the people who do the job, must be factored in. If the new system is a radical shift in their working practices, that may conflict with their family lives. It may conflict with the way they live. It may not be acceptable to them. So it's important that in devising new systems that the people who do the work, the managers and the workers who implement the new system, that it should be acceptable to them. There's also a technical dimension. It's one thing to say this is what's happening at the moment, but this is what we can do. Well, can we do it? Is the technology available? Is the technology sufficiently developed? Has it been tried and tested under these circumstances? It could be a very costly exercise if the old system was dismantled and the new one put in place, but the new one hadn't been tested and it didn't work. That could be extremely costly. And finally, economic. Is the new system economic? The whole idea is to devise a more efficient system. So, does it reduce costs? Does it increase productivity? So, there are 4 dimensions to the feasibility study that need to be borne in mind: legal, acceptability, technical, and economic. Now let's go back to the waterfall system again and look at our diagram for the waterfall for the development of the system. Now we're going to look at, we've done feasibility, so we're going to look at systems investigation, the next step along the line. This stage involves an in-depth investigation regarding the present system. It means looking at the present system very critically and being very thorough in the analysis of the existing system. The purpose of this stage is to identify requirements of present and new information systems. Look at the existing processes. See what information is necessary coming from the existing process, because that may be an indicator of what the new system, if a new system is developed, that's an indicator of what sort of information the new system must generate also. So learn from the old system. Don't just throw it out. Learn from it. Problems imposed by the present system, for example, errors, inefficiencies and shortfalls, these should be noted. What are the problems of the existing system? Because the new system should clear up these problems. That's the whole idea. It's pointless looking at the present system and looking at the errors, perhaps the failure rate in terms of production, within the existing system and then institute a new system which gives the same failure rate. Well, what's the point? So it's important that the present system indicates errors, inefficiencies and shortfalls that can be looked at in the context of the new system, because the new system should address these problems and should fix those problems. And what are the constraints within this system? For example, the financial, the technical, the external. The external could be the legal ones that we talked about in terms of feasibility. It's not just a question of developing a new system. It must be acceptable, as I said earlier, in terms of feasibility, but it must also be legal. And what are the human resources? Perhaps a new system will require significant amounts of training. Perhaps a new system may be somewhat more complex and more difficult to manage and to use. So what are the constraints in the existing system, and look at what would happen if the new system was put in place. And how do the users interact with the system? How do they interface with the system? Let's say it's a production system within a company. How do the workers interact with the system? What parts of the system are automated, if any? What parts of the system are highly sequential? One part must run in front of the next part. What parts run in parallel? So how do the workers interact with the system? However, this could be how do customers interact with a new system. The banks may introduce a new way of issuing cash to its depositors. So a depositor wants some cash to spend. They need to go and get it out. Well, how do they interface with their account? Now, that needs to be well thought out. There are so many issues there in terms of ease of use, that it's error-proof, if mistakes are made that they can be rectified, and so on. It's important to look at the boundaries of the existing system. What are the boundaries? What are the limits of the existing system? So where does the existing system start and where does it finish? And can it be extended? Or can it be filled out in some way? So what are the boundaries of the system? Now, next we have the system investigation. This goes back to our waterfall model. So information is gathered through the following means. We gather information by observation. It's a very useful technique. I have to appreciate that it leads to errors sometimes, or there may be inaccuracies in recording what is seen, but observation is a very powerful technique, and it's a very widely used one. So looking at an existing system and recording what's seen or what is experienced is very valuable. Of course, steps must be taken to ensure the accuracy of what's seen and what's experienced. It could be through interviews. There could be in-depth interviews with individuals and teams, and these may look at the attitudes, the problems, the concerns regarding the present system and a new system. Ask users what do they feel about the present system, how could it be improved, and ask them if a new system addressed these areas, would it be more acceptable. Just interviews to see what their opinions are. It could be questionnaires, mostly used in large organizations. But questionnaires could be sent around to the whole workforce in a large organization, asking them what they feel about a change in the system. So it's investigating the system, the current system, and it's investigating what people feel about the introduction of a new system and what the attributes of the new system would be and what they would feel about that. Look at the organization records and documents. Look at previous trends and statistics. Appreciate that the information can be dated, can be very old and not very relevant, but try to look at past documentation to see what problems were encountered in the past when management tried to change the system, change some part of the production system or the marketing system or whatever it was. What problems arose? Would the same problems arise if the current proposal was put on the table for consideration? Would there be the same objections perhaps? Back to our model, we've looked at systems investigation. Now look at the systems analysis. Well, systems analysis is really, it's the brainstorming stage. Information from the investigation is analysed to form suitable solutions. It's important to look at the existing system, look at the proposed system, look at what information, what data, let's take it as data, what data has been collected regarding the existing system and regarding any proposed new system. And then analyse it, turn it into information and see what the information is telling us. What's the information saying about the introduction of a new system? Would it be acceptable? Is it feasible? Is it possible? Is it efficient? Is it legal? Is it acceptable? So go through the various stages, look at the information and look for criticisms all the time to try and refine the whole process of analysis. Look for the reason for introducing a new system. Don't just introduce a new system because there's a feeling that the old system is outdated. Look for evidence. Is it outdated? Perhaps the old system is working perfectly and perhaps the old system is still the best that there is available. So don't just go to introduce a new system because some time has lapsed. That does not make sense. Look at the impact of the new system. Who will it impact most upon? The workers, the customers, the managers? How will it change the organization? Will it change the design of the organization? Will it change the structure of the organization? So look at the impact a new system will have. Look at the costs and associated benefits of the new system. Changing from one system to another is not costless. The old system has to be dismantled, the new one put in place. That's a cost. And then will the savings from that expenditure justify changing the system? The benefits must be greater than the costs for something to happen. And always look for alternatives. Don't just consider that there is a system, the system is inefficient or is not reliable for whatever reason, and a new system is required, and then look for one new system. Look for many new systems and pick between them. They may need to be customized because of the nature of the product or the nature of the service being produced, but that may still be preferable than just taking the first one that comes along. So always look for alternative systems. And remember, again, to ask, is there a requirement for a new system? As I said earlier, the existing system, as I said in A above, the existing system may be still the best one there is. So approach the whole question with an open mind. Don't approach it from the perspective that there is an old system and a new system is better. It may be that the old system is still the best. And look at the degree of automation and staff involvement. What sort of technicality is going to be introduced? What sort of training will be required for the workers? What sort of conditions of employment will they have? What are the routines of their work? How will it change? And will it mean a change in their working lives? This may impact on them wider than simply going to work. It may impact on their families, or it may impact on the way they travel to work. Suddenly they're in the traffic jam, whereas previously they were able to travel at off-peak times. All sorts of implications for the workers. What new skills will they require? What training will be given to them? And what if the system breaks down? What's their role? Must they fix it, or must they account for the breakdown? Or what new skills will they require? These are very big questions. But before a system is changed, they must be addressed. Now, the system design, which is our next step in the waterfall. System design, well, this stage finalizes a design for the implementation section. So the system design, this is the final bit. Having worked out that a new system is required, the old system is malfunctioning, or it's got too many errors or too many rejects, it's not fulfilling the requirements of the organization, and it's not meeting customer needs. In this case, the new system has now been looked at, and we've now moved to the final stage, the system design. All factors have been considered, alternatives reviewed, and the best solution is carried forward. So we're in the final stage of the changeover. The stage specifies the new requirements of this system, addressing issues identified in the previous system, as I just said. The new system must be error-free, or it must be within a margin of error that's acceptable. It must not be ambiguous. It must not be it must be consistent. It must not be in a situation where today it's very efficient and tomorrow it misbehaves and it breaks down. So it must be consistent. So it's looking at the new system, it's looking at the attributes of the new system, it's trying to decide on what are the bad sides of the new system. Are there bad sides, and how will these affect the organization? So it's been very critical of the introduction of the new system. It's been very critical of just jumping in and changing over the system. Now, implementation, well, provisions should be in place to offer training and development for staff using the new system. There should be training, supervision, documentation and manuals. All the supporting information regarding the new system should be made available. There should be training programs. So it should be a smooth transfer. And issues regarding changes in working practice should be addressed. The HR section should be involved in allaying fears and explaining and discussing the issues with the affected members of staff. And security measures must be in place. The new system must be tested, and the system is easily recovered if there are failures. Security of production is important, and if the system fails, it can be brought online very quickly. If it's a computer system, sometimes a backup system is available. If one cuts out, then the backup system steps in. It may mean some work is lost while the new system comes online, and work which was not previously saved may be lost. But it's not as disastrous as having a single system and having people standing around waiting while the new system is rebooted or brought back online. But the same could apply to a machine. If the machine breaks down, how fast will it take to bring it back into production? And what production will be lost while it's off, and what measures are in place to bring it back quickly? And this could be a function of training and having appropriate people or personnel available in the event of a breakdown who can step in and fix it quickly and bring it back online. The implementation stage could last for several months. The new system works alongside the old system to ensure inaccuracies are resolved and the old system is replaced with the new system. That's in the ideal world. In the ideal world, if possible, the old system is kept running because it's been tried and tested. Everyone's familiar with it, and the new system is phased in. So it's brought in part by part until finally the new system replaces the old system completely. The old system is turned off and the new one is now in place. So it's phased in. And that's common practice, particularly in administration, in areas like education, in some parts of medicine. The old system is kept. The old record system, let's say, is kept, and the new record system is phased in until eventually it takes over and the old one is closed down. System design. Well, the design specifications contain information regarding the capture, input and transfer of data to the new system. So having worked out that there will be a new system, it's important that the information that's fed into the new system can be captured, can be picked up, and then it can be input into the new system, and there is a smooth transfer of data from one system to the other. The processing and outputs of the data, what medium would be used for output? Well, it's an issue. The processing of output, in the past a lot of processing came back on paper, but more and more it's coming back as screen displays. It appears on the monitor, and managers have become used to the fact that perhaps they're not dealing with paper. It's a paperless society. They may be able to make recommendations, read the information, make recommendations and make feedback automated, in an automated way, directly from the screen, which increases efficiency. They don't sit on the paperwork for some time thinking about it and chatting to their colleagues and looking for ideas. They're able to give their feedback almost immediately, and they may be able to update their feedback when they've reflected on the issues at a later stage. So processing output of data is important. Generally speaking, new systems, particularly ones which involve some degree of computerization, processes the data. And the data only becomes information when managers find it useful. It's important that the structure of the system and associated documentations are available. The system specification should have the structure of the systems clearly specified and all associated documentation available as well. And there should be safety and backup documentation, as I said in one of the earlier slides. It's important that the new system can be brought back online in the event of failure. It should be backed up, and it should be easy to bring it back online efficiently and fast. If it's a catastrophic failure where parts simply burn out, then that's a different issue. But many times systems fail because there is some sort of illogicality in the processing of data, or there is an ambiguity in the system that the particular machine is not sure which way to send it, and it simply breaks. So it's important that the whole system is properly configured and it can be brought back and fixed very quickly. Developing documentation for testing and implementation process. Well, developing the documentation, this actually is something which can run with the system. The system will presumably come with manufacturer's specifications. If it's new machinery or a new computer system, whatever it is, it'll come with guidelines from the manufacturer. But when using it and configuring it to the particular requirements of the company, then the company will develop its own documentation. It'll itemize the different parts to the system, timings, processes, and so on. So it'll develop documents for testing and the implementation of the system. And now the implementation stage, or the execution stage. Well, in this process of execution, plans are in place to implement a new system, such as writing computer code and testing, purchase of new equipment, software and hardware. So this is implementation. Everything has been done up to this point. So now it's a question of doing it, putting in the new system. So it's necessary to make sure that all the parts are in place and working properly. All scenarios and consequences need to be considered before the cutover to the new system. Unidentified errors can cause failures of the system and cause shutdowns and cause disastrous consequences for the organization. So it's important to try and anticipate all possibilities. That may be impossible because that's the way life is. Life surprises us all the time. We think we have covered every possibility, with the system into place, and there is a surprise because some part of it fails, which was not expected. That's the way it is. But as far as possible, all possibilities have been thought about, worked out, and considered. So it's important that the new system will work and work effectively. It's important to have good quality control, ensuring all aspects and all controls are in place and the equipment is of satisfactory standard. Good quality, the chances are, leads to good processing and a good result. So when acquiring the new system, when designing the new system, if corners were cut, if economies were sought, which were not perhaps originally in the plan, but these economies could be false economies. They could lead to failure. So it's important that there is good quality right throughout the process, that the best equipment and raw materials and so on are used. Obviously there is a cost aspect to this, and the economic consideration that we talked about way back when we talked about the feasibility study, the economic consideration is still there. The whole idea for the system is to produce a product which will make a profit. So let's keep our feet on the ground. The idea here is to produce something efficiently. So quality is important, but I suppose it must be realistic. The review and maintenance, the last section. Well, for the review and maintenance, the final stage is a continuous review of the new system. Measures are in place to iron out any issues and to ensure the smooth functioning of the new system. It's important that the system is monitored, it's checked, it's measured, it's analysed, and it's important, particularly at the early stages, to ensure that nothing was overlooked. But eventually it should settle into a review process which will maintain the system, will gain more knowledge of the system and also maintain the system. Reviews should be carried out to ensure that the new system meets the aims and objectives set out in the feasibility stage, and cost estimates have been adhered to. So it's important that the cost of the new system is monitored, it's programmed, there's a budget, and that the budget is brought in. It's brought in at budget or just perhaps under budget. If it's significantly above budget, then management needs to inquire as to why the budget estimates were so far out. It's also important that the new system meets the objectives set out in the feasibility study, that it is economic, that it is acceptable, and that it is legal, and so on. So it's important that the new system fits in well with the company procedures, and it performs and functions well within the overall company environment. The process encourages organizational learning to adopt best practice. Well, any new system will mean more study of the system. There will be training programs and updating programs and seminars within the company and so on, looking at aspects of the new system. And the new system itself may be a platform for further revisions to the organization, and indeed may suggest further new systems elsewhere in the company to fit in with this one. So there may be a constant updating of technology and the use of technology within the business. So innovation has come about through the new system, perhaps, and that innovation will spark off further innovations elsewhere in the organization. So this long video, as it turns out to be, looks at a very important issue. It looks at the system life cycle, which is known as the hard approach, and we focused on the waterfall model, and we've looked at a version of the waterfall model which runs through the adaptation of a new system to meet the requirements of the company, and the phasing in of a new system and the phasing out of an old system, and looking at some of the issues that need to be addressed when considering changing systems within a business. There are many resources that can be consulted online about this one as well. But that's all we're going to do at the moment on this topic, so we're going to leave it at that and say thank you for watching.